I'm going to start recording. And I'm going to hide that. Okay, great. All right. Let me change this one last thing and then we will get started. Okay, so basically I am giving you we're going to do a problem that I personally find really tough. And that's just because of how my mind works. I guess here, I'm going to do this so you don't look at the problem and get distracted. Yeah, this is a problem that is really hard. And this is actually what caused me to fail in an interview back when I was interviewing once. Everything went super well and they gave me this problem and I completely tanked because I'm just bad at visual thinking and it was just tough for me. So anyway, we're going to go through this. This is still a problem that I struggle with. But it is not an uncommon, I guess I'm saying that because I'm telling you, it's not an uncommon question to be asked. Like I was asked this, it's in cracking the coding interview. It's not an uncommon question, so it's good to be prepared. And I will do my best to explain it. It's a little tough even for me. But here we go. Okay, so the problem is you're given a matrix, it's square, it's n by n, and they want you to rotate it clockwise. So imagine like when you have a photo and you just want to rotate it like this, you're going pixel by pixel and you're rotating it 90 degrees. So they want you to do the same thing. Okay, and what they say here, actually don't look at that yet. I'll go back to that. So basically the idea is that you're given a matrix, it's in this format, but that means it looks like this. So does everyone know what a matrix is actually first? You see, a matrix is going to represent some type of 2D, it's a table, basically. So the way that you represent that with arrays is you say, okay, this is, can I annotate? Sorry, let me figure out how to do that 1 second. How do I get it back? There we go. Okay. Okay. So this here is the 0th row and the 0th column. This is the first row, first column. Second row, second column. Which means that this is 0, 0. This is 0, 1. This is 0, 2. And what that means is this is row by column. So row 0, column 2. What is this one going to be?
Like 2, 3.
This one is, so what row number is this? This is the 0th row.
One.
This is the first row. And what column number is this?
1,
2, exactly. What's this one going to be?
Yeah, 2, 1.
Exactly. 2, 1. Great. Okay. So this is the idea of, this is in a matrix, it's basically rows and columns. And the way that you can represent it easily, there's a lot of different ways you can do it. Well, we'll talk about that. But basically here, it can give you, if it's n by n, that means there's going to be 3 rows. And each of them has 3 columns. So this is represented this way with this input matrix. And the output, when we rotated it, the 1, let me change colors of my pen. The 1 went here, the 2 goes to this side, right? Basically each edge, like this edge here, oops, sorry, this edge here is going to get flipped. Maybe that was less helpful than just doing this. This edge here is going to get flipped down to the bottom, right? This edge here, 987, is going to get flipped up to the top. There it is, 987. 741 goes up here. 1, 2, 3 is over here. Okay. I know now there's just a ton of drawing all over this, but the idea of a matrix is that you have a set of rows and columns, and now what they want you to do is they want you to rotate it like you would an image. So now this side goes down here, this side here, this side here, this side here. Okay. So let's look at that on the 4. So there's a 4x4 matrix. Let me. There we go. Okay, this is a 4x4 matrix. This. Okay. What are the row and column of this one? What's the 6 here? What's the row?
That means 2, 2.
2, exactly. What's the column?
Yeah, 2.
Oh yeah, third guard, I said it right. 2, 2. Perfect. Okay, great. So here, this 5, 1, 9, 11 is going to go over here to this side, 5, 1, 9, 11. And we're going to do the same thing. We're just rotating that, right? And then in here, this one is going to rotate. So now the 8 is going to go down to this side, the 6 to here, 3 to here, 4 to here. And so that is our final thing, right? So we rotated this side, then we rotated this inner one. Okay. So does what we're trying to do make sense for this problem?
Yeah.
I should say, any questions about it?
I don't know, like in different language, it's called like transpose. Is that the same thing?
I think transposing an array is actually flipping it over a diagonal, which wouldn't. So this is interesting because there's multiple ways to solve this problem, and Tariku, you're hitting on one of them. You can transpose it, which means that you go just this, which means that you take it across the diagonal, and then you're going to flip. This side goes here and this side goes here. And these on the diagonal stay. That doesn't quite get you the rotation, but then if you swap the columns, there's a second step. So you can first transpose it, and then if you swap the columns, it will actually do the same thing. That's not the solution we'll be using today, but we'll go over that one. But transposing a matrix, I believe, is flipping it over the diagonal. But we can confirm that.
Yeah, I just remember the word, but I don't remember.
Mm-hmm. Yeah, I don't fully remember either, but I'm pretty sure that's what it is. But yes, no, this one's a rotation. And it's clockwise, 90 degrees. So we're just moving it one time around like this. Okay, so without thinking of, this is confusing to know how to solve it, but do we understand what the problem is that we're trying to solve? Any questions about we're rotating things, etc.?
So to rotate like 90 degree, only 90 degree?
Yeah, so this is just going to rotate on its side. So it's just going to go here. Yeah.
So it's like changing like rows to columns, yeah? It looks like that.
We'll talk about the solution in a bit, but I just want to make sure you understand the problem. Yeah? Okay. Okay. So this is the thing that we're trying to solve. Now, me go to, I did start recording. Okay. Okay. So, I'm going to try to share something else. There we go. Okay. Okay. So I'm going to try to keep this down a little bit low. Okay. So there's a problem. Given an n by n matrix, rotate it 90 degrees clockwise. So it's this exact thing here. It's what we just saw. This now is going to here. CFI is going here. So we're just rotating it 90 degrees. Here I did the same thing. This was me trying to figure out how to solve it. I just put in the rows and the columns, each one numbered like that. So I'm seeing where they go. The 0, 0 is now ending up over here in the 0 where 0, 2 was. 0, 2 got 0, 0, right? 2, 2 got 0, 2. 2, 0 got 2, 2. Okay, so that's just when somebody tells you, okay, do this, you can kind of just see this is my own process of drawing it out to see where these things have to go. So any ideas on the general, not exactly what we're going to do, but any notices of patterns of something that it is that we're doing? Or like when we are swapping these things.
So the column number becomes the row number.
Yeah, so depending on what we're switching. But it can, yeah. The other thing that is big is that we're working in layers. Okay, so in something like this, we're first rotating, taking this. Where's the? There we go. Okay, we're taking this layer here, and we're this edge, and we're moving it to this edge, and this edge, we're moving it here, this edge here, and then we go to the inside one, and we're taking this edge and we're moving it here, this edge here, this edge here. See how we're doing that? So we're not taking the entire matrix and shifting it all at once. We're taking each edge and moving it over to the next side. Right? So we're rotating an edge at a time. And more than that, actually, we're just rotating one layer at a time, because as we'll see, we won't even rotate the entire edge at once. But we're going layer by layer. So we're taking, first we're rotating this entire thing, and then we go to the inside and we rotate this entire thing. Does that make sense? And if this matrix was bigger, we would have taken this edge and moved it to here, this edge moved it to here, this edge moved it to here, and then gone into this one, and then this one. Does that make sense?
Yeah, I think.
Okay, so we're given this table, when we have to rotate it, we're starting the outside, rotating that first one, then we're moving to the inside, we're rotating that, and we're rotating more and more. Okay. Okay, so basically, let me tell you how this went for me. The interviewer said, we have an n by n matrix, try to rotate it. And didn't give, and that was it. And so I was trying to think about it. I think I probably drew something like this. This was many years ago now. I think I tried to draw something like this, was trying to figure out, okay, what is each thing getting? Got really overwhelmed. And then and I was trying to talk out loud. So the interviewer knew that I was struggling and said, okay, try to think about this in layers. You're going to move one layer at a time. So this is how it tends to work, where you're going, you get stuck on something. It's totally fine if you're stuck, but then they'll give you hints as you keep working through it. So that's what I'm going to do. And that's why I'm keeping this screen kind of small, because I have hints as we scroll down the page. But we will try to fill out, I've got partial functions as we go down, and we'll try to fill them out as much as we can before we go to the next hint. Okay, so first off, we're working these layers and we're going to try to rotate each layer. So there are two basic ways that we could do this. I actually kind of touched on one of them already. And let me, okay. Yes, any ideas on how we would be able to move things around with a general algorithm? I'll give you one way, and then you can give me another idea. Let me make this bigger for you. So one way would be to grab this entire edge. You could copy it into an array, and now assign this entire edge gets the top, this entire edge gets the side, this entire edge gets the bottom, this entire edge gets the left. Actually, you would need to do it in a bit of a reverse, because you end up missing a thing. But that's the idea. You could go and move the entire edge. But this is going to necessitate, if you move the entire edge of something, you are going to need to have an additional array. So right now they give you a matrix, which is an array of arrays. If you were to save an edge and move things around, if you remember our swap functions from previous algorithms we've done together, when you're swapping, when you're saying this edge goes here, this edge goes here, this edge goes here. Let's do this in this column. So let's say you're going to assign, you're going to say, okay, this side on the right is going to get the top. This on the bottom is going to get the right. It's going to get the right. Oh, but you can't do that. You have to go the opposite way, because right now you can see on the bottom gets the right, but you don't have the right saved anymore. So basically what I'm saying, when you're swapping things, let's say you're doing it in a simpler way. Let's say you have variable A gets 3, variable B gets 2. And let's say you want to swap A and B. How would you do it? How do I have B get 3 and A get 2?
Like to swap A and B?
Mm-hmm.
So
yeah, how would I do
like
that?
we will create like new variable like C, for example.
Okay.
Then C equals A, for example.
Okay.
Then we can say B equals A. Then A equals C.
So now both B and A are.
Okay, so C should be B. C equals B.
Let's say C gets A. Let's keep it that way. What would we have to change then? You're super close.
Then A equals B. A equals B. Then B equals C.
Perfect. Okay, great. So exactly as Strika said, you couldn't just say A gets B and B gets A, because if you did A gets B, A is 3, B gets A, well, now A is not what it was before, so now it's going to get 3 as well. So you need to have this, which is your temp. A lot of times it gets called TMP or temp or something like that for temporary variable, it's just your holder. But using C works super well as well. It can just be convention. So when you're swapping something, you need to hold it somewhere. So if you're swapping an entire edge here to bring it back to the array, to the matrix, if you're swapping an entire edge, you need to hold one of the edges so that you know what to put in this last one. And the issue with doing that for a matrix is totally fair. The issue with doing that is that now you've created your space complexity is worse, because you now are creating a whole other data structure that needs to hold n. It's gonna add an O of n onto your space complexity, because it needs to hold whatever this length of the array is. And it's going to do that at each layer. Okay, so one way was to move the entire edge. What's another way? Instead of moving the edge, what's the way we can do this in place? We can go pixel by pixel, or cell by cell, or place by place. So instead of moving the entire edge, we're just going to take this guy and he's going to go down here. And then this guy is going to go over here, right? And that it'll keep going. So we're going to go each one by each one. First, we'll swap all the corners, right? This guy goes here. And now this guy goes here. So we just swapped all the corners. And now we're going to go here. This guy is going to go, it's where the corner was +1, right? It's going to go to its corresponding index. This guy's going to go here. And now the guy that was here is going to go over here. And now this one is going to go over here. Now this one is going to go over here. Okay, and we keep going like that. So this goes here, this guy goes here, this guy goes here. And now I've just swapped an entire layer. Okay, so instead of swapping an entire edge and saving this into an array, we're just going to have one variable that's similar to this. It's going to hold whatever was in this index. And then we'll swap things around. Okay. Okay, so this is the algorithm we're going to work with. Okay, we're swapping index by index. We start in the corners, we swap all the corners, then we go to that place +1. So now we're swapping corner +1. Now we're swapping corner +2. Now we finished that row. Now we go here, we swap the corners, and now we're actually done. This is the whole length of the thing. If there were 4, this would actually be better if I had. Let me see if I can paste in. Sorry, hold on. Oh my goodness. Okay, great. So same thing here. You can see the Visual Studio, right?
Yeah, I can have it.
Okay. So same thing, right? We're moving, swapping the corners, goes here. And now this corner goes here. This one goes here. And this one goes here up to the top. Now corner plus one. This guy goes here. This guy goes here. Here to here. Here to here. And so on, right? Does this make sense? There. This. 14. Okay. Okay. And then we've gone through the entire length. And we're done. We've swapped them. And then now we move on to this inside, etc. Okay. Great. So this is what we're going to try to work on. Any questions?
No.
Okay. So here is our dummy function. Rotate matrix. So first, if, what's our base case here is that if the matrix doesn't exist, we should return false or return something. You can put that in. If there's no matrix, just return. But if the matrix, we know it's an n by n matrix. So if the length of it is just 1, so it's a 1 by 1, rotation is the same thing. We should just return back what we get. That's our base case. Right? This is our edge case. Okay. So now this is our general format that we just talked about. For each layer, so we want to rotate each layer. So for each layer, we're going to do something. For each layer, for the width of that layer, so in this case it's 4, in this case it's 2, we want to rotate all elements of the corresponding index. So the 15 is going to go, or the 5 is going to go here, 11 here, 16 here, 15 up here. Right? So we're going to rotate each one of that index and keep going, as we just talked about. Okay, so first, let's try to figure this out. So for each layer, let's say, so let layer get 0. A layer is less than something. Okay. So for each layer, we want to do these things. So how do we know how many layers we're going to go through? So we're going to have an n by n matrix, which means that we'll have this is a 3 by 3 because it's the length of it is 3. And in each one, there's going to be 3 elements. But because it's 3 by 3, we know the length of this. There's 1 row, 2 rows, 3 rows. Oops, 3 rows. So this is the number of rows, right? The matrix dot here, matrix dot length is equal to the number of rows or columns. Does that make sense? Because the number, it tells us the number of rows. And we know that the number of rows and the number of columns is the same. So here you go. The length of this matrix gives us the number of rows. Now, so this has 4 rows. And there, how many layers are in this matrix? How many times are we going to go through and rotate the layers?
Like 4 times.
So it's a 4x4 matrix, but we rotated this. By layer, I don't mean edge, I mean an entire layer. So we rotate this, and then we rotate this. So it's actually 2 times. Yeah. And let me do something else. And this one,
That looks like is the matrix length minus 2 times
wait, is the matrix length what?
minus 2.
What if you had a matrix that is 50 big? It's
Oh,
50 by
okay.
50. So it's not minus 2. Here, let's see, this one's 3. Matrix length is 3. And we just rotate it 1 time. Right? Because now it's just 1 element, so we don't need to rotate it. So 4, we rotated 2 times, divided by 2. Exactly. So the number of times we're doing this is it's going to be the like math.floor, the rounded down version, although it actually won't matter because we're just saying less than, the matrix length, half of the matrix length. Because it's going to be, it's how many times did it take to get from the top of this matrix into the center. How many layers are there to get to the center? And that is only half. Like, where's the, sorry. Here. To get to the center, we're saying, okay, it's going to be 1, 2, and here's the center. In this case, the center is nothing. In the other case, it could be 1. To get to the middle means 0 or 1 element in there. So this one's 1, 2. And that's because we're going from the top and we're saying, okay, how many layers do we need to drill down to get to the center? So it's half of the width of the array, or of this matrix, right? 4 would mean we're going all the way down to here, but we're actually stopping in the middle. So that's why it's going to be layer is less than exactly what Ming just said, matrix.length divided by 2. And we can put this in a variable just to make this easier. The number of layers is going to be this. Okay. So this is our for each layer. And this is telling us, okay, we're going to go through this 1 time. You could literally have a function in here for each layer, swap layer elements or indexes. Okay. So for each layer, swap that layer's indexes. Okay. So if this function already existed, we would be done. For each layer, go and swap all of the indexes in that layer. Make sense?
Yep.
Riku, Javier?
That takes care of the outermost layer.
This will, so let's pretend that we had a function that would swap all of the, that will rotate. Maybe instead of swap, we should say rotate. Rotate layer. It will rotate a layer.
Okay.
So we had a function that will just take, that is given a matrix. And the layer index of which to to rotate, and it will just rotate all of the elements in there. So it's given this matrix and it said, okay, here's the matrix, and I'm giving you the 0th layer, which is the outermost layer. We could have it start from the inside and go out, but we're gonna have to go from the outside, start in. So, okay, start from the 0th layer, which is out here, and rotate the whole thing. Now go to the next layer. So the first layer, passing the matrix, and now the layer is 1. So it knows, okay, go in here and rotate the whole thing. So if we had that function that existed, this would solve the whole problem, because we've got, okay, we're just trying to say, okay, for each layer, rotate that layer. So this is going to tell us which layer in the matrix to rotate. So this is layer 0, green one. And this, and this is layer 1. So for layer 0, rotate that layer. For layers 1, rotate that layer.
Got it.
Okay. Okay. So this is just us, this is our outermost function. It's saying, pretend we have a function that says rotate layer, and you can make this function, right? You can do this in an interview to say, okay, for each layer, rotate layer. Now I'm going to create the rotate layer function. And it just needs the matrix and the layer number. Okay. So for each layer, so layer 0, layer 1, rotate that layer. Any other questions about the number of layers, how we're going through this?
Nope.
Okay.
Yeah,
Okay. Great. So now we're going to make this part, the rotate layer function. That's the hardest part. Okay. Also, don't worry if you have questions. This is, again, I told you I struggle with this problem so much. So this is really hard. So definitely ask a lot of questions. Okay, but we'll move on if everybody's clear for where we're at now. So basically, we're rotating one layer at a time. And now I've got our loop to say, okay, for each layer, rotate it. Now we're going to build this part out here. And this part out is what we have here for the width of that layer. Right, so now for each layer, for the width of that layer, so we're going to go through each of these elements, rotate all elements of that index. So we're going to, that's what we were talking about before. We're taking this one, 15, and oh, sorry, it's the other side, isn't it? We're taking the 5 and we're moving it down here. Taking the 11 and moving it down here. 16 to here, 15 to here. And now we're taking the 1 and we're moving it to here. The 10 to here, 12 to here, 13 to here. And so we do this for the length. So for each layer, we're moving the corners, then the corners +1, corners +2. And we are doing this for the we need to know where to start and where to end, right? So we know which layer to start with, the 0th layer. Now we're going to go to the first layer, and we need to know, okay, we start at the layers index, but now where, because we're given the entire matrix each time, right? Rotate the layer, we're given the matrix and the layer number. So now we just need to know, okay, to make the next for loop, to go through and say, okay, for each of these, we're going to rotate them, go through each column and row and rotate it. We need to know the start and end indexes, so we know where we're going to start rotating. So if you're given this layer, if you're given this matrix and they tell you, okay, rotate layer 1, you need to say, okay, rotate layer 1. It's going to start at, what was this? Remember, what was the row of this one?
Starting at 1, 1, 1.
It's going to start at 1, 1. Exactly. And it's going to end where?
Yeah, 1.
1, 2. So the length of it is going to be 2. Right? So here, our starting index is just going to be the layer that we're at. And our ending index is actually, let's say it was index 0, might be clearer. Okay. Here, we're starting at 0, and we're ending at the matrix.length, which is 4. But we're actually ending here, right? Remember, we were swapping 5. By the time we got here, we've already finished. We've already swapped that corner. Does that make sense? Should I explain that more? When we're here, we swap here, the 5 goes here, the 11 goes here, etc. Now we swap the 1 here. The 1 here. This goes here. Now we swap the 9 here. And now we stop because we've already, this is the next corner. So we've already swapped the 11. Right? So we went 1, 2, 3 times. So we were going the matrix length minus 1. Does that make sense?
Is it length minus 2?
No, it's matrix length minus 1. Because we're stopping
Oh,
here.
that's right. Oh, that's right. Okay.
Okay. So it's the matrix length minus 1 is where we're stopping. So we're starting at 0 and we're stopping at 3. Like before we get to 3. Right? So while it starts at 0, well, it's less than 3. And that will stop us here. Okay? Does that make sense? We start at 0, we're stopping at 3.
Yep.
Which is the matrix length minus 1. Now, here, we started at 1, we're stopping at 2. And the reason why is because it's matrix length minus 1, but minus the layer number that we're in. So minus another 1, because now we're in set 1 more. If there was something else in here, it would be matrix length minus 1 minus 2 layers. So we're just subtracting the number of layers to get to where our ending point is. Okay, so we started at 0, we went to the length minus 1. Now we started at 1, we went to the length minus 1, minus another 1, because now we're on the first layer. Okay, so this is going to be that's going to get us the width of the layer. We're just trying to get what we're passing into this for loop. Okay, so we are passing into this for loop. We're trying to get the width. So how many times within this layer are we going to need to be moving numbers and indices around? Okay, so we're trying to say, okay, what's the width of it? It's starting at layer. So here our layer 0. Here our layer is 1. So starting at the layer number. And it's ending at, make sure it's the length minus 1 minus the layer number to get us here. We're inset by 1. Here we're starting at 1 and 1. I mean 1 and 2. Here we're starting at 0 and 3. Does that make sense?
Yep.
Yeah.
Okay. Great. So, this is actually where we are. And here we go. So our start index is the layer. Our end index is the matrix length minus 1. And then we're taking off, we're insetting however many the layers are. So this is just getting us the width of whatever layer we're looking at. Okay. So this is our rotate layer function, is all what's coming in here. So now we're saying, okay, in this rotate layer function, we're going to go through the length of this. And for each one, we're going to rotate the corresponding. We're going to rotate the corner here, then here, then here, then here. Now go on to the next index. We're going to rotate here, then here, then here, then here. Go on to the next index, here, then here, then here, then here. Done with that, go on to the next layer. Okay. So this is what we've already done together so far. Okay. So here we've said, okay, for each layer, go through and swap first the corners, and the corner plus 1, and the corner plus 2, until we get to the width of what we're trying to swap, which is going to be the full thing minus 1. And now go on to the next layer and do the same thing. Okay. So now in order to make that swap, to say, okay, here we're looking at this, we now have the layer and we have our starting and ending index. So here it's going to start us at 0, it's going to end at 3. So while I is less than 3, so that'll get us from 5, 1, and 9. We need to now swap the top side of this, and then the right side, and the bottom, and the left. Okay, so now let's just try to figure out, how do we get the top index? So the variables that we have right now are the start index and the ending index. And we have I, which is telling us which number in here, like if this is the 0th, right? And then this is actually start index. This is start index plus 1, start index plus 2. End index is our last one. Right, so end index actually is here. It was 3, right? So end index is getting us, here's our starting index of the row. Here's our ending index of the row. And those are the variables that we have. And something that actually would be helpful for us is to make an offset variable as well. So the offset is saying, okay, where how, like, this is an offset of 1, because so first we swap the corners, and now we're going to swap the second element, and now we're going to swap the third. So let's get the offsets that we know. Okay, in our row, what is the offset from the start that we're at? So that offset is going to be, any ideas?
1.
Like, how far are we from the, well, if it's always 1, that would always get us here, right? So here the offset is 0, here it's 1, here it's 2, here it's 3. But that's because our start index is 0 and our end index is 3. But let's say we were in here. So here our start index is 1.
End index minus start index.
Yeah, so it's actually going to be I minus start index. And that's because so it's telling us, okay, here our start index is 1. It's going to be, but our offset in this row, it's got to be start, and we begin at start index. So here the offset is 0. Even though the index of this is 1, even though the start index is 1, our actual offset is 0, because this is where we're starting the layer. Here, the offset is 1. I know we wouldn't actually get to this corner because it doesn't work that way, but let's say we did. Here, the offset is going to be 1. And that's because it's I, so I has gone up. So now we've gone to the next one, minus the start index. So it's just saying, okay, how far on this row are we? Like how far have we progressed in this row? This is just going to be helpful for us. You could do it without this, but it's going to be helpful for us. So we've got an offset variable, which is just saying, okay, how far, like here, the offset 0, then it's 1, then it's 2. Here, if we go down here and 0, and it's 1. Okay, we're just saying, okay, what number in the row are we switching now with all of its corresponding things on each side? Okay, so it's I minus start index. Okay, so just remember that is getting us where in the row we are that we're switching. So now, how do we find each of these? Oops, tricks. The top index. What will our top index be? Actually, we need to save the top first before we do anything, just as Tariku said with our swapping stuff. So let's save the top index. Okay, so what is that going to be?
I and offset.
One of them is going to be I. So the top is going to be, remember, starting with 0, 0. And then it's going to be 0, 1, then 0, 2, and 0, 3. So what is the thing that's staying the same each time? So in each of these, we're looking at the top, the left, the bottom, and the right. We're
The
looking
top
at, we're
Oh,
looking
it's
at
the
each
layer
of these.
number.
Yeah, so each of these on the, if we're looking at the top row, the side column, the right column, the bottom row, or the left column, for each of them, either because they're rows or columns, either the row stays the same or the column stays the same. So here for the top and the bottom rows, the row is going to stay the same. And how are we going to know which row it is?
It's the I.
It's not I, because I is changing as we're going through, right? It's actually the layer number, which is our starting index.
Oh yeah, layer.
So here we were at layer 0. Here is layer 1. That's our starting index. This is where it will be I. Because now we're going 0, and then we're just saying, okay, we're going up 1 each time. That's our offset. Sorry, it's not our offset, but it's we're going up 1 each time. So the row is 0, and we're going up 1 each time. Okay, so we just now, this is us just saving the top index. Great. So now what is left? Okay, so now the top index, we just figured it out, right? It's a matrix of start index of I. Great. We're gonna assign it to something. I'm just trying to get an idea of what these are first. So now how do we access the left index? So going to the left
This is
side
the
here.
I. The first one is the I.
The first one will be changing, but it's not just I. So here the left index is 15 here. And how do we figure that out? So it's any ideas?
Like matrix links,
Hmm?
like matrix links.
So it's, yes, matrix length, which is so it's not going to be just matrix length, because remember, it depends on our layer as well. but it's the right idea, Driku. What you're actually looking for is end index, because this is going to, remember now, basically our matrix and our matrix length are more defined by start index and end index. This is telling us where in the layer we're going to start rotating. So end index, yeah. And importantly, it's going to be end index minus offset, because we're thinking about it as we're changing through, right? So now it's going to be here, and now here, and now here. So our row is changing. So it's end index, and it's changing by the offset that we're going through here each time. So now instead of row 3, it's row 2, then 1, then 0. Okay, offset is just a counter. It's just that we can't use I because I isn't starting at 0. So it's end index minus the number of times we've gone through this loop. This is the one that will stay the same, and what will that be? It's going to be start index.
Yeah.
Right? This is where we're starting this layer from. Great. Okay, how about the bottom? So we're here, and then going here, and then here, and then here. Here, what's staying the same, the row or the column?
Start index or end index.
It is end index, yeah, because the row is staying the same. And we're just switching the column number, right? And the row is end index, absolutely, because we're at the bottom here. Now the column number is going to be, it starts at end index, but it needs to change. So what do we need to do?
Plus offset. I mean,
Minus offset,
it's offset.
because we're subtracting, we're going left.
Yeah.
But perfect. Okay. And now the right side. So now we're here. And we're going down here. So what's staying the same, the row or the column?
Column.
What?
Column stays the same.
Exactly. And what is it? What is the column going to be?
And index.
Yeah, it's going to be end index. Okay. And then what about the row? We're here, and then we're going up and up. But we're starting at what number row? What number are we starting the row at here?
Like start index.
We start at start index, exactly. And then we're going up and up and up, right? So this is actually just going to be I. We start at start index, and we're just going up 1, 2, 3, 4. So matrix of I. Perfect. Okay, this is the hardest part. Great. Crushing it. Now let's go down here. So this is, now we're just moving them around. We stay to the top index, and now the top index, which we already found here, is going to get the left index, which we'd already calculated here. The left is going to get the bottom, which we calculated here. The bottom is going to get the right, and now the right gets what we saved as the top. Okay? So this was basically us just now saving one and then swapping them all around. This is our rotate layer function. Or this actually is our rotate layer function. Okay. This is rotate corresponding index function. Okay. So now, let's say we had an array like this exact matrix that we pass in. Let's see if it works. And it does. That looks perfect. Okay. Any ideas on any questions? And then we'll go into complexity. Any questions? I know that's quite a lot. It's very confusing.
Yeah, I think it's a little bit complicated, I think I didn't understand most parts, I think
Yeah,
maybe, yeah.
I
Like,
understand.
yeah. I think I need to stick like for a long time, to understand something.
Yeah.
Yeah.
Well, you should definitely try this on your own and try other questions that have to do with matrices. Because it's super confusing. I'm with you. I couldn't do this problem. I didn't want to teach it because I hate it so much. But it does get asked. So good idea to have.
Yeah, this one's a little tough one. Did you do it on your interview?
No, I was not able to do it at all. No, it was really bad. No, but it worked out completely fine. It's fine if you like bomb an interview or if you don't get a job or something like that. Like I learned a lot and it's good. Things worked out very well, but no, I did not do well on this problem at all. But the main thing that they really want to see, like looking back on that interview, I don't think they really they either expected me to have practice cracking the coding interview and this appears there. And so they either were expecting me to know it from that, or they really just wanted to see how I thought. So the most important thing would be speaking out loud and just kind of saying, okay, I'm actually not sure how to do this. I think I see that you could rotate it each layer. Here's the general idea of an algorithm. But it's definitely a struggle. I know that I started out drawing everything like this, being like, okay, I see that this is getting rotated here and this is rotating here. And just trying to pick out patterns, but honestly, it did not go well. It's tough. This one's particularly tough. And I think most interviewers know that as well. But yeah, don't worry if you don't fully understand it, just the general idea. That's the most important thing. If somebody gives you a problem like this, just saying, okay, I think rotating in layers makes sense. I think like, here's my very general, this is why I wrote it out in these smaller pieces. Like, okay, here's my general algorithm I'm going to try to follow. Okay, I'm going to try to get the start and end indexes so that I know where to start rotating.
Can you I'm trying to think about the end index where you subtract 1, or where is it at?
Wait, sorry, what?
Yeah, the end index. If you go
this here.
Yeah, where you subtract the layer.
Mm-hmm. So your starting index, you're saying, okay, given this, like, we're saying, okay, what is we're trying to get the length of here, we're starting at 0 and we're ending at index 3. Here, we're starting at index 1 and we're ending at index 2. Right? And that's because we're saying, okay, we're going to, it's basically our column index, but it's just to know how big. So we've got the layer, which tells us how deep into this matrix we're going. And we're saying, okay, for how many indexes on this row do I have to switch with all of its corresponding ones before I can move on to the next layer? So your end index, you find your start index, so it's just the layer number. And your end index is, you're now just you're calculating it the opposite way. You're saying, okay, it's the length the -1 is just that you don't swap a corner twice, but it's your length minus the layer number. It's the same thing as your starting index starts with the layer, your end index is just the length -1 minus your layer number. So it's the same thing. You're just going in an even amount on each side. Does that make a little bit more sense, maybe?
Yeah, a little bit more.
I know it's a lot to wrap your head around. I honestly still don't have my head wrapped around it. It's tough.
I feel that offset is kind of it takes some time.
Yeah, I didn't understand that also, like offset.
The offset is yeah, okay. The offset is just our counter. So the offset is like basically normally your I is your counter. It's, you know, I starts at 0, it's going up 1 and 2, etc. Here, our I is starting at some number we don't know. Our I is starting at 5, right? It's our starting index. It's the layer that we're at. So I is starting at 1, I is starting at 2. So our offset is just saying, okay, if we were starting I at 0, what rotation are we on? What iteration are we on? So it's just saying, okay, I, which is it starts off at starting index, I minus the starting index. So it's just setting this to 0. So when you subtract starting index, you know you're gonna get 0, you're gonna start it back at 0. So it's just a counter. So because starting index, let's say we were at layer 5, this would be, well, I is layer 5, well, I is less than 10, plus plus. So we start off with I is 5, I is 5, and start index is 5, right? But this is actually our 0th iteration. It's going to be I minus start index. Now I plus plus, I is 6, but it's our first iteration. 6 minus 5 gives us 1. It's just saying this is where we started off. And it's telling us, okay, here we're swapping the corners, so it's the 0th element. Here we're swapping the corner plus 1. It's our first element. Now we're swapping plus 2. Okay, it's just a counter of what number we're at in this row. Does that help?
Yeah, a little bit.
Do you have any more confusions or questions about that?
Can you scroll up just like 2 or 3 lines?
Like that?
Yeah, that's good.
Okay. And we're getting late, so I'm going to post that, don't worry. But I wanted to share 2 other things. First, what is our time complexity? Our space complexity, we did this in place. So let's answer that first, actually. We did this thing in place. So what's our space complexity?
O of 1.
Yeah, well, it's going to be O of, actually, I think it's going to be O of n. You're right, O of 1. Yeah, because we're not making anything else. Okay, right, so we're not adding anything else, right? We're not creating the other array to swap all the edges. So it might be, no, yeah, it would be O of 1 because you're just making one variable in each round. Okay, great. What's our time complexity?
N square.
Exactly. We've got 2 loops and they're going through each thing. Great. It's got to touch each element in this matrix, and any matrix is going to be O of n squared because it's nested rows and columns. Okay, so now going back to what Triku was getting at before, I just wanted to share there's many different ways to do this. I did not find this website very helpful, except that they showed, oh, it's not very zoomed in, is it? Here you go. There's different ways to do it. So there's the way that we did, which is the most popular method, but there's another way you can do it with multiple loops. You can fold it over diagonally and then fold it over vertically, right? And then so you can transpose it diagonally and then do that same thing over the columns, and it will give you a rotated matrix. Okay, there's a bunch of different ways to do that. If you want to look into other ways to do it, you can look into it here.
Yeah, thank you. It's good. Yeah.
Yeah, you're gonna flip it over the diagonal and then flip it over the middle column. I still find these a little confusing, but it's all confusing.
What's the space complexity if is it the same, or if you're using
It's the same thing because you're doing it in place. So you're saving the temp variable. It's the same thing. You're not creating a new array. You're not creating a new data structure. You just have one variable that holds the variable you're swapping. This is still all O of n squared because it's 2 times n squared, which is just n squared. Okay, also a great solution. When it says auxiliary space, that means space complexity. Okay, so there's different ways you can flip it. There's different ways you can do this. Okay, so I'm going to send the code that we did today. I'm going to put that all in the doc, and it has a link at the bottom. It has the link to the site I just showed you. And then you can look at the different ways to solve it there.
Okay, thank you.
Yeah. Okay, I'm
Yeah,
gonna stop
thank you. Yeah.
recording.